So I'd like to spend a bit of time discussing my involvement with Algonquin College. I'm a professor, a part-time professor in interior design degree program, and I've been teaching there for about 5 years. And recently, just this year, we are starting to implement building biology principles into the curriculum. And all our students, upon graduation, will receive a building biology advocate certification. So that means they understand the principles and the education that go into building biology, which is phenomenal from my point of view. To bring building biology to a lot of youth is going to be essential, and to start with interior designers and all the health related impacts of that program are essential. We're also going to get into a lot of EMR and EMF just awareness, which Europe has started. They've made some progress with eliminating EMF and EMR, or wireless anyway, in some of their colleges, and especially their grade schools. But I find we just haven't picked up on it at all, and it's only getting worse. And so it'll be interesting to show interior designers how those type of components work. One of the big things we're going to be working on.
You've got some cables here.
Oh yeah.
So you're shielding all your electric fields?
So in this house, we can talk a bit about that. We are creating shielding for all our wiring, for all the I guess wiring or low frequencies that come out of that. We are also putting in kill switches in all our bedrooms to create the sanctuaries. From a low, everything will be hardwired. We won't have any wireless devices inside the house. Our cell phones, which unfortunately you can't live without these days, will be turned off when we're in the house, and we'll be directed to a landline telephone, just to keep a bit of a sanctuary inside our house from all the wireless outside.
How about electric meter?
We do have a smart meter at this point. Unfortunately, it was a requirement by our electrical company. We will be in the process, once we move in, to look at alternatives and how we can get that hardwired again.
Is it Ottawa Hydro? Do they have a knocked out?
Hydro, yeah, and they were going to charge us $6,000 to remove the smart meter. So that was unacceptable, and I'm told there are some Ontario provincial legislations that will allow us to get a hardwire system and remove the smart meter for free, but it's not very well known in these parts. So I have to look into that, and as soon as I find out, I'll be spreading that word pretty quick. There's a lot of wireless out, even just from cell signals and other local smart meters from neighbors. I mean, all those wireless things penetrate most homes. And what really fascinated me when I dove into some building biology, and even Paula's homes, is that the EcoNest homes, is that Paula always mentioned that the EcoNest home tended to block a lot of those signals in itself. And it was largely because of the clay inside the walls. I don't know if that's the mass or clay itself. I've recently, we have a colleague of ours in our office who did building biology studies in Europe. And he's done a lot of work with EMR and EMF, including testing and diagnosis for a lot of clients in Norway. And,
what's his name?
Aaron Fabian.
F-A-B-I?
Yeah, F-A-B-I-A-N. So he was originally from Canada, but he lived in Norway for about 7 years and adapted building biology principles into his practice there. What was interesting was his comment that he's always known clay to be a shielding technique for EMRs, which I find pretty fascinating, and maybe another significant contribution to this, essentially the first building material that ever existed, clay. It does so many wonderful things. Japanese reports from their plastering companies are looking at studies that show that clay plaster naturally absorbs and breaks down formaldehyde from the air. It's phenomenal, phenomenal stuff, and it's by chance more than anything, because it was here long before formaldehyde was, and it's a very, very how you put it, therapeutic material to build with, because it understands so many of the things as an architect we try to avoid on so many levels, and that's really trying to control weather and control how water penetrates our buildings. But clay naturally knows how to deal with a lot of these substances.
It's anti-static also?
It's anti-static, it brings in a lot of negative ions, it just helps contribute to all the health that unfortunately our industry don't fully understand. But now my students are starting to, so that's a huge step in the right direction. Mm-hmm. I did want to showcase very quickly a section through our wall. This is a piece that was cut out. You can see just how dense it is. This little piece contains a lot of clay, as you can see. And there is straw, there's a lot of air pockets, so that's all your insulation. But that clay has bound itself to all of those fibers. So it soaks up the water as it goes through a wall system. And a large reason homes like this that have been built for, 800,000 plus years still are inhabited, continuously being inhabited for that duration. So it's refreshing to see a wall system with very little maintenance can last several, 500 plus years. And once it's done its life cycle, it goes back into the earth, essentially where it came from. And from an ecological point of view, our mission is to build healthy buildings, not only for humans, but for the ecology itself. So health on all levels.
Where do you think the housing industry in Canada will be in a dozen years? We talk a lot about 2030.
Health. I believe health is the next big one. And they'll talk about, to start with human health and hopefully adapt into ecological health, because the two go hand in hand. Natural materials are just naturally healthy for us, just like our food industry has gone to understand all the ingredients that exist in the food industry. Now I think it's time for the building industry to reveal all their ingredients so we can see what the effects of these materials are. Now I think 5-10 years, all people will be talking about is health, and the whole energy movement will be part of that equation, but it'll have a much more holistic approach to building, and hopefully a much more ecological and carbon friendly and ecological health. Yeah, it's really going to be about health.
How about wetlands? I heard on CBC yesterday Ontario lost 72% of its wetlands because cities were built on them, and that's why there's flooding all over the place.
Yeah, I believe it.
Can we rebuild wetlands?
No, I don't think very successfully. It takes takes hundreds and hundreds of years. No, we need to change. I think cities are starting to realize that, and we can do Living Building Challenge again that we've been involved with. One of their challenges is that you can't use any new land to build on in urban centers. You have to use a gray or a brown site, and that's significant. That makes us rethink our cities. We can't rebuild them, but we can start to adapt and live within them. We don't need to expand more. That I strongly believe.
The Green Building Challenge also wants you to be energy and water autonomous, self-sufficient.
Yeah.
But they're against wood heating, eh?
Living Building Challenge is against wood heating, but I don't think they fully. For starters,
Montreal's banning wood heating this fall.
Well, Ottawa's trying to too. But the problem is people aren't heating with this. This has a sealed door. It has a sealed unit. I'm told the heat that gets distributed from this, there is carbon emissions, but it's very minimal because the burn is so long. It's like 2 hours for a few logs because it has channels inside this very vague old technique of burning really high and really long. It comes down both sides, goes through the bottom and then up the chimney. That's an extremely long, how do you put it, burning session. And because of that, it does help with that emission that we're talking about. It's a much cleaner way to run a fireplace. A lot of fireplaces are open, so a lot of the heat gets distributed out into the building. Fireplace is straight up, your chimney. You lose a lot of heat in that process as well.
I'm told an EPA stove is cleaner, but you're going to burn your EPA stove all day and all night. This is what, 4 hours a day and night?
Well, yeah, 2 hours max.
But two burns,
Two burns
on very cold
about
days?
an hour each. Yeah, no, and so you're burning it a lot shorter time periods. That's very, very right. And, you know, anyway, I'll get to understand this a little better this winter, but I have a feeling that the amount of energy that this will consume compared to, you know, our alternatives, I think will be very, very interesting. But the fear is that we use very inefficient wood burning sources to heat our places. So you're constantly burning in order to heat. There's no storage capacity. There is no other capabilities of, you know, doing something like this. You burn for an hour to 2 hours and you store that energy. This will hit its hottest peak close to 10 hours after the fire goes out. And that says a lot. Most fireplaces hit their peak while that fire's burning. This is 10 hours after.
And with climate change, we're going to have more hail and power outages. You'll be able to go through it.
And we'll be able to cook using it. So there's multiple different benefits, but you know, there's always the other side. Living Building Challenge definitely tries to move away from carbon sources of energy, which I think are good, but you know, I think we just haven't seen all the different parameters. Like for example, we are the first, what I would consider truly natural building prototype for Living Building Challenge. I mean, we haven't got that certification yet, but we are the first time clay straw is used, or a lot of other natural products that we are using in that building. So hopefully it puts a few other natural materials on the radar.
How about PV? What are you planning?
For PV panels there, the client is still pretty adamant.
What's not here?
Oh, here? PV panels, I'm not sure. I would like them away from the house. I just haven't decided where and how that's going to work yet. I don't really want them on our roof from an EMR and transmission point of view. There's a real conversion that happens and a real dirty electricity that can penetrate the wiring systems of homes and the transmitters themselves. The conversion of DC to AC power is quite can be quite harmful to a lot of individuals. So it'd be nice to remove that and create a little bit of a barrier or a sanctuary between our home and those type of panels. So they might go on top of a garage or some other element. I'm also looking at some alternatives to producing electricity. I'm, very early stages of that though.
It's all in AC, it's not DC, the house, the wiring? Or?
I wish it were DC, but it's all AC. It's almost impossible in the city to avoid AC.
Yeah.
It's easier if you rely only on PV panels and bring in DC directly.
Surely if you're sleeping close to the panels, you may be getting electromagnetic fields, but even if the panels would be outside, the power converted would have dirty electricity. Are you wired? You're not plugged in yet?
No, we're not.
Okay.
No, we're
about you're going to test for dirty electricity?
80%. We'll have to Yeah, I mean, there's always tests for dirty electricity.
Who's your inspector?
From an EMR point of view, Aaron and myself are going to be doing kind of the initial looks at it, and we'll probably get some building biologists long term to confirm what our testing mechanisms are. You know, Safe Living is a big organization out of Ontario that deal a lot with it, so I do see us collaborating for sure.
They have a great new meter. They're safe and sound.
Yeah, we purchased one recently, so yeah, it's great.
Okay. What else have we not covered? Windows.
Our windows are Martin windows, Martin out of Quebec. I love the French style. I only went with double pane windows because I like the, you know, the features that double pane allow instead of a triple pane window. And it, I like the French hardware. And more importantly, I love, again, you know, it's that fine line of what is essential to the initial component. Is whether, you know, heat loss is one aspect, but you get more heat gain if you go with the double pane and have less of the panes out. But also, I really like the idea of opening the entire window for full ventilation into the space. When you open a double window like that and have that type of ventilation, it makes a significant difference to the interior.
And out here we see Duracell blocks.
Yes.
Describe your foundation.
Extremely messy backyard. The Duracell Blocks, wonderful material. We used it for our foundation. They can give anywhere from an R15, I think, all the way up to an R30, and depending on the thickness of the block. So you have a block that's made with wood chips, clay, and cement. They're processed in Ontario. They've been around much longer than any other ICF product, the plastic equivalents. And it uses a product called Duracell inside of its inner core.
Now called Rockwool.
Rockwool, yes, it has changed its name. I like Rockwool. The only problem I have is the fact they still use formaldehyde in their production. So it does contain small traces of formaldehyde, which we're trying slowly to make people change.
So you want to avoid concrete for your blocks?
Yeah, so this reduced a lot of our concrete load. Concrete's quite carbon intensive. And again, when you're looking at, you know, energy efficient homes, you're trying to eliminate carbon, so you try to do it the best you can. And I find an ICF product really gives you that added bonus of having insulation as well as some thermal mass and protection for the concrete. So the concrete provides all the structural qualities that you need for a foundation. But I find these panels, they tend to protect with the clay, with the cement, the wood chips, and everything else. They protect that concrete, and they help that structure to last a lot longer. Some people don't see it that way, but the structural engineer made a very interesting comment to me in that light, and it really makes a lot of sense that your foundation can be much more sustainable and long-term using panels like this.
But here you don't have a basement, it's a slab?
It's a slab on grade, yes.
And the blocks are only on the perimeter?
It is only on the perimeter. They have stem walls,
it's
so
the footing?
all of our walls come up to this point. So we have Duracell around the first foot of the walls, just to raise our clay straw slightly above the ground.
Okay.
And it helps with any home, any wood construction. It's better to get it and raise it off the ground from a moisture point of view.
So they're on top of the slab?
Yeah. Well, and they go down. They're also there for frost protection. They go down 6 feet. Okay. So we have a big foundation walls because our footings had to be 6 feet below grade for frost protection in this area. Yeah, so they act as stem walls essentially around the entire perimeter.
Okay.
And we have a very tiny crawl space where a lot of our mechanical systems will be stored.
Okay, cool.
Yeah.
Well, thank you very much, Bobby.
Well, thank you, Andre. This is lovely, and I'm look very much forward to our next conversation.
Yeah, we'll have to get a busload of Quebecers out here
Yes, that's
next year
right.
once you're all finished.
That's right. Well, thank you so much.